Okay, you guys, this is all of chapter 3 exam review. I will walk you through every single question. Reach out if you have questions. You got lots of people in the room that know how to do everything on here, so ask for help if you need it. Okay, so 6 and 7, when you're graphing an inequality, I just need to see the number that you're graphing. And then keep in mind, this is greater than, there's no equal to bar. So that's gonna be an open dot because we don't include the 5. And then if x is greater than 5, as long as your variable's first, remember we said you could turn that into an arrow. So that would be an arrow that points to the right. So x is greater than 5 would look like that. Number 7, your number is a -1. And it's less than or equal to, so that's pointing to the left, but this has the equal to bar, so that's a solid dot, and it's less than goes to the left, so it's gonna look like that. All right, these next two, you have to solve the inequality first and then graph it. So you're gonna go +6 and +6, so v is less than 10, so you plot your 10, you ask yourself open or closed dot. In this case, this is an open dot. And if v is less than, it goes to the left. Everything less than 10 would be over there, and that would be your answer. 16, you are adding a half. So now this, you're adding fractions, right? So it's going to be n is greater than or equal to whatever that comes out to. So let's just lay this out. 3/4 plus 1/2. When you add fractions, you need a common denominator. So 1/2 is the same as 2/4. So 3/4 plus 2/4 is 5/4. So you may write it like that. N is greater than or equal to 5/4. Or you could write it n is greater than or equal to, that would be 1 1/4. Or I don't even care if you write it like this, 1.25. So if you think about where that would fall, if you're going to put numbers, here's 0, here's 1, here's 2, right? 1 1/4 would be a fourth of the way between 1 and 2. So this is going to be a closed dot because of that equal to bar, and n is greater than that number. So everything greater than 1 1/4 would be this way. Okay. 19, it says you have at most $15 to spend. You want to buy a used CD that costs $4.25, right? And solve an inequality to find the possible additional amounts you can spend. So you can spend some amount plus the $4.25 of the used CD, and that amount, if you have at most $15 to spend, so the 15 is going to be your standalone, you got to really stop and think about what this means. This amount, whatever you spend, has to be less than or equal to 15 because you can't spend any more than 15. Okay, so this amount is less than or equal to 15, and then you solve it. So write the inequality, that's this part. Solve the inequality is take away the 4.25 and you get x is less than or equal to, so this is going to be 10.75. But remember, on word problems like this, I want to know what you mean. What does that mean? So we would say you have to spend less than or equal to $10.75. Okay, so make sure you label it and explain what it means. All right, 21 and 22. With inequalities, remember when you divide by a negative, like we would have to do here to solve this one, that's when you flip it. Okay, so don't forget to flip this greater than to a less than, and then that's a -3. And I didn't tell you had to graph on this one, so you just leave it as T. Oh, in my answer key, I didn't flip it. Shoot. So t is less than -3. If you're looking at the answer key, it's wrong. Maybe by the time I'll fix this and get it back to you. Okay, 22. So you're going to multiply by 3. So y is less than or equal to 6. That one you don't flip because it's not a negative. 28. Says you earn $7.25 per hour. Remember, per is often times, right? Times the number of hours for babysitting. Write and solve an inequality to find how many full hours you must work to earn at least $200. Okay, so set up the inequality. 725 times the number of hours you work somehow relates to 200. So if we want to earn at least 200, then we want this number, this 725h, to be greater than or equal to 200. Because if it was less than 200, then you're not making at least $200. So this is your setup. Now you solve it. So divide by 725, and you get h is greater than or equal to, oh, I didn't work that out. What is 200 divided by 725, and you get 27.586. So the number of hours has to be greater than or equal to 27.5. Now it says how many full hours must you work to earn at least $200. That means you would have to work at least 28 full hours. Okay, if we're talking how many full hours of something, then you gotta round to the next thing. Okay, number 30. 30 is solve the inequality. My son Zeke was just doing these yesterday. So distribute this, and you get 6c minus 6 is less than -18. So then your next step is you're going to add 6, and you get 6c is less than -12, and then you would divide by 6. So c is, now we don't flip it. Even though there's a negative here, we only flip if we're dividing by a negative, and we are not. So c is less than -2. All right, back up to the top. Solve each compound inequality. So you're just solving these as two separate things right here. On the left, we're going to divide by 2. So t is less than or equal to -2. Or divide by 7, and t is greater than or equal to 7. Okay, so that will be your compound solution. The next one is more of an and problem, right? When it's in between like that. So whatever you do in the middle, you can do on the left and you can do on the right. So -1 plus 3 is 2, which is less than or equal to a, which is less than or equal to 2 plus 3, which is 5. And that would be your solution. All right, number 50. So this says solve each equation or inequality. If there is no solution, write no solution. So I just want you to see, none of these have no solution, but I do want you to just remember what does have no solution. If it's the absolute value of something equal to a negative number, okay, that's when it's no solution. These ones, none of those are like that. So these don't work out to that, but just so that you see this part of it. You won't actually put no solution on any of these ones. All right, so number 50 here, you have the absolute value of n plus 2 equals 4. And remember, absolute value, so whatever's inside of this could equal a positive 4, or it could equal a -4, and you would still get a 4 over here, right? Because you're taking the absolute value of it. So that's why we write it as two equations. We say that n plus 2 inside could equal 4, but that n plus 2 inside could also equal -4. And then we just solve both of those. So take away the 2, and you get n equals 2. And then take away the 2 here, and you get n equals -6. So those are your two possible solutions for this problem. Remember, when you're solving with absolute value, you don't write the two inequalities or two equations until you have isolated the absolute value. So you want absolute value to be all by itself. The way we do that here on this 55 is we got to add the 1. So now we have the absolute value of 2x minus 7 is greater than 1. And then once you're here, now you can write the two inequalities. But remember, with inequalities, so with equations, right, with an equal sign like we had up here, you just write it as equals the positive and equals the negative. But with inequalities, it's different. So you need to write it as what you see it first. So 2x minus 7 is greater than 1. But then the other inequality is going to be the same 2x minus 7. You flip it and you make it negative. Okay, so those are the two inequalities that we're going to solve. So we're going to add 7. So 2x is greater than 8. And we're going to divide by 2. So x is greater than 4. Okay, if you recall, when you get to this point, this tells you if this is an and or an or problem, right? This is greater, so this is an or setup. So we're going to add 7 on the other one, and we get 2x is less than 6, and divide by 2, so x is less than 3. So x is greater than 4 or less than 3. Okay. All right, last one. Again, with this one, you need to isolate. So what you're going to do is you're going to divide by 4 first on both of those, and you get the absolute value of k plus 5 is greater than 2. So again, this is an or problem. You're going to rewrite your two inequalities. So the one as you see it, k plus 5 is greater than 2. And then the other one, k plus 5 is less than -2. So we're going to subtract 5. So k is greater than a -3. Or, greater, take away 5, k is less than -7. Okay, so k is greater than -3, or k is less than -7. And that's it. That is kind of the core concepts of chapter 3. But remember, you can always use your tests, your quizzes, any of that stuff to study. Those are good ways to practice as well.